When we generally think of a telescope, magnification naturally comes to mind. Most people would think that a telescope is used to magnify an object so we could see it better. And while this is still accurate, it isn't the whole truth.
You know, we're pretty lucky to have telescopes. For most of human history, we've been looking up into the night sky with nothing but our naked eyes. Now, of course, our puny eyes can't compare to the magnificent power of the telescope. But why? How do they work? And how do I use one? Let's go inside and talk about it.
When we generally think of a telescope, magnification naturally comes to mind. Most people would think that a telescope is used to magnify an object so we could see it better. And while this is still accurate, it isn't the whole truth. Telescopes essentially have two jobs. Firstly, a telescope must gather information in the form of light. The more light it can collect, the more information it can give you. An optical device, such as a lens or a mirror, is used to gather this light and is called the objective. The bigger the objective, the more light it can gather. Let's say it was raining outside and you wanted to collect as much water as possible. You wouldn't just use a small cup. You'd prefer to have maybe a bucket, or even better, a swimming pool. That's exactly how telescopes work. They could be exponentially larger than the pupils in our eyes. They could collect way more light. Secondly, the light collected by the objective is then focused, concentrated, and sent directly into your eye, like a funnel for light. It is the job of the eyepiece, the second lens in the telescope, to capture that light and spread it over your retina, magnifying the image. Without that second lens, no image can be created for your eye to see. It is the eyepiece that determines the magnification and field of view of your image. History time. Now, you might think it was Galileo that invented the telescope, but that's not actually the case. The invention is widely credited to Hans Lippershey, a Dutch eyeglass maker. Galileo only heard of the invention and decided to make one of his own design to be used for astronomical observations. This version of the telescope is called a refractor. Why? Well, as light bends or refracts when it changes medium, like with a straw in a cup of water, or these lasers changing directions, the use of a lens to funnel the light is where these telescopes get the name refractor. It was Galileo's amazing discoveries using his own version of the telescope that probably spread the misconception that he invented it. Some of these include the moons of Jupiter, the rings of Saturn, sunspots, and the phases of Venus. Unfortunately, there are many problems with Galileo's refracting telescope. The glass used in lenses absorbs many wavelengths of light. Glass can also be very heavy and tends to warp. Lenses must also be polished from both sides, and it can be difficult to keep one in place using only the edge. Another problem with refracting telescopes is chromatic aberration. Different colors, so different wavelengths of light, bend at different angles when changing mediums. The result is a fuzzy rainbow effect in the image. So, how did we solve these issues? I'll show you. Though he may not have been the first to conceive of the idea, Sir Isaac Newton was the one who solved these issues with his invention of the reflecting telescope. The key difference between a refracting telescope and Newton's was the use of a mirror as opposed to a lens as the objective. Newton polished a curved and circular mirror to reflect light towards a secondary mirror that then bounced the focused light into an eyepiece on the side of the telescope. The single-sided mirror allowed for easier mounting, and there was no chromatic aberration. These types of telescopes are now referred to as reflectors, or Newtonian. Almost all telescopes used today in astronomy use mirrors as opposed to lenses as their objective, but there's nothing wrong with using a refracting telescope for backyard observations. They could still be fantastic telescopes.
There are also hybrid telescopes that use a combination of both lenses and mirrors to form an image. These telescopes are called catadioptric. Incoming light enters the barrel through a corrective lens, which reduces aberrations. The light reflects off the large curved primary mirror into the secondary mirror. It is then directed towards an eyepiece in a hole in the primary mirror. There are plenty of other types of telescopes, but they're all basically different variations of these three: refractors, reflectors, and catadioptric. Time to talk about light.
Telescopes are not limited to the visible spectrum of light. A telescope refers to any device that can detect any part of the electromagnetic spectrum. Our eyes are only sensitive to a small sliver of it, so many other wavelengths of light we just can't see, like the infrared or radio waves. Interstellar objects like stars emit more than just visible light, so there are radio telescopes, infrared telescopes, X-ray, and even gamma-ray telescopes. Observing astrophysical objects through many wavelengths of light can yield very different information. For example, here's an image of the Crab Nebula in visible light, the remnant corpse of an exploded star. We can now see what it would look like through other wavelengths. Here is radio, and now infrared. But look at X-ray. At its very center, we can now see the rapidly spinning neutron star emitting beams of energy. A pulsar, the collapsed core of the now dead star. These images and this information just wouldn't be possible without the other wavelengths of light. The telescopes you're most likely going to be using here on Earth, however, only use visible light. Speaking of telescopes on Earth, they kind of have to face a serious problem. Atmospheric disturbances like turbulence cause distortions in the image. You could keep magnifying as much as you want and can never get it clear enough. This is why we see many observatories atop tall mountains in secluded areas. They're not only trying to get away from light pollution, but the atmosphere gets thinner the higher you go. Sadly, the atmosphere also absorbs many wavelengths of light that we want to observe, like X-rays or gamma rays. So, what if you could get rid of the atmosphere altogether? You can, by sending your telescope to space. The Hubble telescope is the shining example of spacefaring telescopes. Launched into orbit in 1990, it is probably the most well-known telescope ever. The images taken by the Hubble telescope have been capturing the world's imagination for the last 30 years, and have led to some amazing discoveries. Unfortunately, Hubble won't last forever, though its successor, the James Webb Space Telescope, is set to launch in 2021. Telescopes are tools that need light to function. However, all of the light from the images that we've been observing took time to get here. Light is not instantaneous. Light has a specific speed, and it takes time for it to travel from one location to the other. The speed of light, 300,000 kilometers per second, is the fastest thing in the world, the speed limit of the universe, as far as we know. It takes around 8 minutes and 20 seconds for light from the sun to travel to the Earth. If the sun were to suddenly vanish from thin air, well, we wouldn't know about it for 8 minutes and 20 seconds. So that means when you stare out into the stars, you don't see what they look like right now, but rather what they look like in the past. Same goes for us. The galaxy NGC 4845 is located over 65 million light years away. If there was an alien civilization living in that galaxy, and they were pointing a telescope at Earth right now, they wouldn't see humans smiling back at them. No, they would see the dinosaurs. Time travel is real. Never mind science fiction's depiction of going back to the past, whether it be Doctor Who or Back to the Future, time machines already exist. They're called telescopes. Now that we have gone over the basics, we can now learn how to actually use a telescope. Make sure to check out our channel to see when other videos come out. But until then, I've put several resources and links in the description of this video if you want to learn more. You could also come by and see us at the Planétarium Rio Tinto Alcan in Montreal. We'd love to have you there. And I'll see you next time.